Well, welcome back to our lesson. Today we are talking about how to solve compound and absolute value inequalities. So those are our two learning targets, and a compound inequality is basically just an inequality that has two inequalities in the statement, and those inequalities are joined by the word and or. And when we solve those, we basically break those inequalities up into individual inequalities. The graph of the compound inequality that has an and with it is an intersection of the solution sets of the two inequalities. The graph of the compound inequality that has an or in it is called the union of the two sets of inequalities. And those with an and are called conjunctions. Those with an or are called disjunctions. So a little bit of vocabulary for you there. So let's jump in and figure out how to solve some of these compound inequalities. Here I have a compound inequality. Right here you can see there are two inequality signs in the statement, and we're going to solve this by breaking this up. So eliminate the right-hand inequality and rewrite it. Eliminate the left-hand inequality right here, and then rewrite that one, and we're going to solve those independently. So on the left-hand side, subtracting 2, we get 2x is greater than or equal to 1, and x is greater than or equal to 1/2. And we can write that switching sides, but keeping the open side of the inequality toward the variable. Then on the right-hand side, subtracting 2, we end up with 2x is less than 4, which gives us x less than 2. So combining these two, we want both of these at the same time, or the intersection of those solutions. So we want x to be less than 2, but we also want x to be greater than or equal to 1/2. So in interval notation, the 1/2 is included as an endpoint, the 2 is not, so 1/2 has a bracket and the 2 has a parenthesis. So graphically, this solution would look like all of the solutions greater than 1/2 but less than 2. It's the intersection between those two. Here's another one for you, but this one has the word or in it. So we want y minus 2 greater than -3 or y plus 4 less than or equal to -3. Solving each of those for y, we get y greater than -1 or y less than or equal to -7. So this time we want the union of those two, and the -1 is not included. There's no equal to with that. The -7 is included, so in interval notation we will have two separate intervals, and it's the union of those two. So from -infinity to -7, that's everything less than -7. Everything greater than -1 is included by the interval from -1 to infinity. -7 is included, it's a bracket, it has the equal to. -1 is not included, there's no equal to, so that's a parenthesis. And a reminder that infinity always has a parenthesis, never a bracket. So the solution set for this one, if we have y greater than -1, that's this graph here, y less than or equal to -7, and we want the combination or the union of those two. So the graph at the bottom is the solution graph. So we want all of the stuff to the right of -1 and all of the stuff to the left of -7. An absolute value inequality can be solved by rewriting it as a compound inequality. So this is where we're going to give you some definitions here for solving absolute value inequalities now. If it's a less than or equal to, then that is an intersection or a conjunction, okay? And if it's a greater than or equal to, that is called a union or disjunction. And I'm going to give you some important definitions here. These are very, very important. Symbolically, if we have the absolute value being less than a number, then that means we're going to have that absolute value function is less than this right-hand side, and it's also greater than the opposite of that. And we solved absolute value equations recently, so this is going to be very similar. So for example, if we have this absolute value inequality, what we're going to do is we're going to say 2x plus 1 is less than 5. That will be one of our inequalities, okay? But we also want an inequality that says 2x plus 1 is greater than negative 5. Now, I'm not going to solve that right here, but I will go on in the next few slides and show you how to do these. On the other side, if we have the absolute value greater than a number, then this is an OR function. It's drop the absolute value, A is greater than B, or A is, and then this flips. A is less than negative B, or the opposite of B. So here's what you would do for the exact same function, only switching this inequality. 2x plus 1 greater than 5, so you're always going to get the one where you just drop the absolute value. The other one is change the inequality to the other way and change the right-hand side to be the opposite. So these are a little complicated. I'm going to start out very basic and show you the difference between the absolute value less than 4 and the absolute value greater than 4. So here we go. We want to solve it and graph the solution. If the absolute value is less than 4, that means that the distance between A and 0 on the number line is less than 4 units. So that's going to be a conjunction. Okay, less than 4 units is everything from 0 to 4 in both directions. So that's the intersection of those two things. So we could say that A is less than 4 and A is greater than negative 4. We can write that as a single statement, or you could write it as two different inequalities. A less than 4, and then you would have to have the word and A greater than negative 4 is another way you could write that. Okay, down on the bottom, this one says the absolute value is greater than 4. Well, we want the distance to be greater than 4 on the number line. So if that number is greater than 4, we want everything from 4 out. It doesn't include 4. So the only difference is if this said greater than or equal to 4, these would be closed dots. But it's the same kind of graph other than that. So if we want that distance to be greater than 4, it's everything greater than 4 or everything less than negative 4. So then our solution would be A greater than 4 or A less than negative 4. So make sure you understand the difference between the and the or. Or always goes with greater than or equal to, and always goes with less than or equal to. Make sure you understand that difference. So this one, solving this absolute value, graph the solution set on a number line. This says greater than or equal to, so greater than is an or statement. So we want 3x minus 12 greater than or equal to 6, or drop the absolute values, flip this and negate the right-hand side. So 3x minus 12 less than or equal to negative 6, and then solve those independently. Going to zip through that, not take a lot of time with that. You know how to do the math on that. So we have x is greater than or equal to 6, or x is less than or equal to 2. Representing that in interval notation, our endpoints are included this time. All the numbers that are less than 2, okay, go from negative infinity up to 2. It includes 2. And then all the stuff that's greater than 6 goes from 6 to infinity. And the stuff in between is not included because it's an OR. Graphically, it would look like this. Closed dots on the endpoints and moving outward. Here is your lesson check, 4 problems for you. Make sure on numbers 1 and 2 that you state your answers in interval notation, and then also graph it on the number line. We'll see you next time.